Okay, so now that we know how to find the derivative of any function, let's do an example. So suppose that we look at a very simple function first, just a regular quadratic. So consider a very familiar parabola given by y is equal to x squared. And that is your f of x. So y equals x squared, so the function is f of x being x squared. So what if now we say at any given value of x of interest, we want the slope of the function. At that point, we want the derivative. Well, as we know, the derivative is the slope of the tangent line at that point, which we denote by dy over dx, or f prime of x. So let's see. If you remember, the derivative of a function, and keep in mind the derivative is just a fancy word for the slope of the curve, which is the slope of the tangent line. So we take the slope of the secant line, so f of x plus h minus f of x divided by h, and to make the slope of the secant line become the slope of the tangent line, we have to let h approach 0. So let's see what happens. The limit as h approaches 0 of, okay, well, f of x is equal to x squared. If you want f of x plus h, well, we are replacing x by x plus h. So if you replace x in here by x plus h, you get x plus h squared minus f of x, which is simply x squared, divided by h. So, well, let's square this. Let's expand and see what we get. So if you square x plus h, you'll have x times x, x squared, plus x times h, plus h times x. This will give you plus 2x h, plus h times h, h squared, minus the leftover x squared, and we divide by h. Notice that on the numerator, x squared minus x squared both cancel, and we're left with 2xh plus h squared. Both 2xh and h squared are multiples of h, so we can factor it. And if we do, we have h times, if we take away h from this term, we have a leftover of 2x, and if we take h from h squared, we are left with h. And this is over h. Now again, as h approaches 0, h is very close to 0, but not exactly 0, so we can cancel the h on top and bottom. So what do we have here? Well, hopefully, a very simple limit. We are left with 2x plus h as h approaches 0. Well, as h shrinks to 0, we're left with 2x. So there you have it. The derivative of x squared is 2x. So let's summarize. And we can write this in a few different ways. So we can write, so the implication here, our conclusion, we can write dy over dx equals f prime of x, which is equal to 2x. Or, the problem with this is you may forget what the function was in the beginning. So you can say or. Well, look at this notation right here. It's d over dx, right? So it's d over dx of what? So the d over dx means the derivative and now we took the derivative of which function? Of the function y, right? So we take the derivative of y, and y is simply the function x squared. So we can replace y in here by x squared, and we know the derivative, right? The derivative of x squared is 2x. So there you have it. So think of what this is saying. This is saying at any given value of x, no matter which x you choose, take the point on the curve that corresponds to the x value, and you ask, well, what's the derivative of the function? What's the slope of the function? Therefore, the slope of the tangent line. And the slope is quite simply the derivative, which is 2x. So at any point on y equals x squared, the slope is 2 times the x value. Let's consider an example where we pick an actual value of x. So let's ask the following question. Consider y equals x squared. And let's find the equation of the tangent line when x equals 3. So find the corresponding point on the curve. Y is x squared, so if x is 3, 3 squared is 9. The corresponding y value is 9. Draw the tangent line, and we want the equation of this line, right? So the equation of a line is y equals mx plus b. Okay, so, well, what do we know? Well, we know that the slope of this line is the derivative, right? So recall, the derivative, d over dx of x squared, is simply 2x. Or if you prefer, you can write f prime of x equals 2x. So this is the slope of the tangent line at any given value of x. So consider the equation of the tangent line, y equals mx plus b. There are two unknowns here. There is m and there is b. But m is the slope of the line, right? And there's two ways to write this. So m is the slope of the tangent line. Well, by definition of the derivative, it is the slope of the tangent line. So m equals the derivative of x squared. And specifically, we want the slope at the point x equals 3. And so if you have an equation that is a function of x, and you want to evaluate the function at x equals 3, we can use a vertical bar and say vertical bar x equals 3. What this means is evaluate the expression at x equals 3. Well, the derivative is 2x, and we wish to evaluate this at x equals 3, so we just replace. The slope everywhere is 2 times x for any given value of x, and specifically we want the slope m when x equals 3. So it is 2 times 3, which is 6. Now that's one way of writing the derivative and at a given x value. You could have also written m equals using the f prime notation, right? The slope of the tangent line is the derivative, so f prime. At which point? Well, we want specifically the derivative, the slope at x equals 3. So you can write f prime of 3. Well, f prime of x is 2x. Now we are replacing the x value by 3, so we get 2 times 3. And once again, the slope is 6. So two ways of evaluating the derivative at the point of interest. So now we know m, right? So m equals 6. So we're halfway done. The implication is the line, that is the tangent line to the quadratic at x equals 3, has an equation of mx plus b But as m equals 6, y is equal to mx, 6x, plus b. The only left over here is, how do we find b? Well, we know that the tangent line passes through this point, and this is the point x equals 3, y equals 9. So since this point is a point on the tangent line, it has to satisfy the equation of the tangent line. So the point 3, 9 must satisfy the equation of the tangent line. So we can replace. When y is 9, we get 6 times x, which is 3 here, plus b. This is 9 equals 6 times 3 is 18. Subtract 18 from both sides, and you get 9 minus 18 equals b. But 9 minus 18 is negative 9. So you have b. And now you have the equation of your tangent line. Y is mx plus b. M was 6. 6x plus b, negative 9. So if we go back, with the curve y equals x squared, when x is 3, the tangent line is 6x minus 9. And that's it.